So we are going to look at creating a regression function with our TI calculator to model this set of exponential data. So in this problem, and this is coming from my Pearson homework, but in this problem we have census workers have walked around and they've determined how many unoccupied homes there are, and they took the census and determined this in 4 years, 1965, 75, 85, 95. And we're going to refer to those years as year 0, 10 years later, 20 years later, 30 years later. And there were 5.2 million unoccupied homes, 7.8, 9.9, and 14.3. So we're going to use our TI graphing calculator to create a exponential function that will model the data, and we can use that exponential function to predict. All right, so in this situation, the first thing I'm going to do, and I'm going to want my diagnostic on. So we always do this first, and if you've already done it in your calculator, it's probably still on. But we're going to hit second catalog, and then we're going to choose x to the -1 power because there's a d above it. And then I'm going to scroll down until I get to diagnostic on, and then we'll hit enter to bring it on the screen and enter to turn that on. It's done. You shouldn't have to do that again. All right, so now I want to enter my data. So I'm going to go to edit under stat, and I'm going to choose enter, and I'm going to enter my data. Make sure your x values are in the L1 column. Remember, we're going to type 0, 10, 20, and then 30. Make sure it all looks correct. Arrow over to the L2 column. Your y values have to go into L2. So we've got 5.2, 7.8, 9.9, and 14.3. Make sure everything looks correct. Again, x values in L1, y values in L2. If your data doesn't match, then your calculator is going to do the correct calculations for the incorrect data. So you have to have that in there correctly. All right, so the data is in there. So we'll second quit, get out of that screen. I'm actually going to go to y equals, and I just want to think about what my data might look like. So if you arrow up to where it says plot 1, you can just turn that on. And then it will be on, or you can hit second y equals and you see the plot 1 is on, and it's drawing your x's from L1 and your y's from L2, and it's going to mark them with this little dot. So now I'll hit graph, and we can't really see anything that's going on there, but our calculator has some great zoom features, and I'm going to hit zoom and arrow down to option 9, which is zoom stat. Then I've graphed my data on the screen. Remember, in the X column, we're thinking about years, and in the Y column, we're talking about millions of unoccupied homes. And, what are the X min and the X max? Well, we're going from -3 to 33, and that makes sense, 0 to 30. And then my Y values, I actually like to think about this, we'll say like -5, and I'll make it go up to say 20 because I just like a little extra space. I want to see those axes. So here we see that data, and it could be modeled as linear, but we are going to use an exponential function. So I would look at this and say, hey, it's a little bit linear, but it also has a tiny bit of a curve to it. All right, so that's not necessary. You don't have to do that, but it's kind of helpful, and we're going to compare the function to the graph in the calculator. All right, so we'll quit out of that. We've looked at our scatter plot. So we want to actually develop the exponential function. Remember, we want to have turned our diagnostic on first. So now I'm going to go back to stat, and I want to calculate. So earlier in the semester, we calculated a linear regression, option 4. But now, because we're in the exponential section, we're going to look at an exponential regression. So I'm going to choose option 0, and I'm going to hit enter. X's are coming from L1, Y's are coming from L2, enter. Frequency less doesn't matter. We can choose to store the regression equation into the y equals, and I'm going to take that option here. So I'll hit variables, arrow over to y variables, enter, and we want to store the function into y1. So we'll hit enter one more time and calculate. So this is the information that we need. So notice this is an exponential regression, y equals a times b raised to the x. So 5.32765, etc., that is my a value, and b, 1.033, is my b value. So we're going to put that over here and say this, notice this says round to 6 decimal places. So that's 5.327,659, and that's going to round up to 60. That is 6 decimal places. And then my b, 1.03327, and that 3 is going to round up to 4. Okay? So this is our exponential function that is modeling the data. So now this is saying, hey, let's think about that graph that we just considered. So I'm going to go over here and hit my graph, and we see the curve is traveling through those data points that are in our calculator. When you think about graphing this, now I chose my scale to be a little bit different. If you want to make yours match what you're seeing, you're going to need to choose, this is x-min, x-max, y-min, y-max, your x scale, and your y scale. So I'm going to change it just a little bit. It says x-min is -2, and x-max is 40. My x scale is 2. We've got -2, 20, and my y scale is 2. So now I can see my curve. I would choose this graph right here. This one is the one that matches what I see on my graphing calculator when I match the scales. Okay, and then we want to use the function found in this part to predict the number of unoccupied homes in the 2005 census. So 2005 would be 40 years after our initial year of 1965. 2005 minus 1965 is 40. So that means I want to take my function, and you'll notice that the function that we plugged in here, it has a whole lot of extra decimal places. I'm going to go in and make sure this matches. I'm going to delete those values. We said that was 660. And then these, I'll delete some of these. We had 7. That guy turned into a 4. That's too many decimal places. 03327. This guy was the 4, and then the rest were deleted. All right. So that's just kind of a helpful feature to copy and paste it in there. And of course, we want to use the exact function, the exact function that's in the Pearson problem, not the exact or their closer, more precise function from our calculator. So I like to use my table to help me choose, and I have previous data in here. Let me delete that out. We said we wanted to look at 40 years later. So 40 years later, it is predicted that there will be 19.7, of course this says round to 1 decimal place, million homes. So that will be 19.7. And we've got that correct. Of course, we could predict for, 2015 or 2025. Now, I don't know if this is accurate data, oops, I didn't put the correct number in. 2025 would be 60. All right. So you can see that the number of unoccupied homes is steadily rising, and it's rising at an exponential rate. So I hope that helps you understand the problem. You might see a couple like that in the homework. Of course, when you are doing homework problems, there are different ways that we can form a regression function. So we can do a quadratic, a cubic, a quartic, or even a natural log regression. Option 8 here is a different type of linear regression. All right. Please let me know if that doesn't answer any of your questions or if you need help with anything else.